All right, ladies and gentlemen, ready to be awesome again. We've got day 2 of scientific notation. We've got our operations. We're going to be adding or subtracting. So I can add and subtract scientific notation numbers, then solve word problems. So some of your homework is going to be looking at, okay, do I need to add or subtract these numbers together? Or maybe even do I need to multiply or divide based off the previous lesson? So we're going to teach you 2 methods on how to complete these. One of those methods is very important to make sure that the exponents must be the same number. So it's kind of like fractions. You know how you learned in elementary school that you can only add or subtract fractions if they have the same denominator? Same concept here. You can only add or subtract your scientific notation numbers if they have the same exponent. So method 1. In order to do method 1, we're going to go ahead and use our scientific notation rules a little bit to manipulate the problems so that they would have the exact same exponent. So if you notice, I've got an exponent of 2 and an exponent of 3. And what we found with our students is it's always easier for them to change the smaller exponent into the larger exponent. So in other words, my third power, the second number, that can actually stay the same. My first number, which has the second power there, 10 to the second power, that's the one that's going to have to change. And if you notice, a 2 has to change by 1 to become a 3. So that means I'm going to have to move my decimal 1 place. So if I move it 1 place, my 3.4 actually becomes a 0.34. Now, if that really isn't making that much sense to you, then maybe method 2 is your option. But we'll get to that in just a moment. So now that I have the same exponent and you have a calculator, all I need you to do is add up your decimal numbers. So maybe you can even just do it in your head. 0.34 plus 4.57. Calculate it in your head. And you have, when you add those together, 4.91 times 10 to the third power. Now remember, we're going to go ahead and double check just to make sure that our final answer looks good, meaning is it the 1 through 9 option. 4.91 is totally satisfactory. We have a power or exponent of 3, so we are good to go there. Method 2 on that problem would be the following. It says convert to standard notation, essentially your normal numbers. Now the one drawback about this again is that sometimes those numbers are a little bit larger than we'd like to work with, but since you got a calculator at home, it might be doable. So 3.4 times 10 to the second power, that is a big number because it has a positive exponent. My exponent tells me I need to move my decimal twice. So it's really going to be, okay, I got a 0.4, so I got to move it 1, 2, 340. 4.57, I need to move it 3 times because the exponent is 3, 1, 2, 1 more, I got a 0 there. Now that I have my numbers in standard notation, I can go ahead and add them up. And now that I have them added, I can go ahead and reconvert or convert them back to scientific notation. So if you remember, I got to think about, okay, where is my decimal at? It's at the back. How many times do I need to move it? 1, 2, 3, and that's why I have a third power there. So again, going back for some of you here. It's currently here, put a dot there, and we want to get it between 1 and 9 something. 1, 2, 3. So that's how we get the 4.91 times 10 to the third power. So again, make them have the same exponent or make them both standard notation. Final answer, third power. All right, the next one, we're going to go ahead and subtract really quick. Now remember, in order to add or subtract, we need to go ahead and make sure that they both have the same power. So we're going to go ahead and try method 1 again. Method 1 means move your smaller or change your smaller exponent into the larger exponent. And if you remember, -6 is actually smaller than -5. So that's why I'm moving it, 1 space on the -6th power problem or number. So when I do that, it's going to be 0.79 because I really just got to move it 1 space, -5. Now, the trick or the key issue for some students is, well, sometimes I have to move it twice. Sometimes I have to move it 3 times. But we're really just concentrating on 1 time right now. All right, now that I have the exact same power, I can go ahead and subtract it. Go ahead and type it into your calculator. Instead of an 8.41, it is now going to be a 7 point something. 7.62 times 10 to the negative 5th power. Now, if you notice, the 7 is between 1 and 9, so we're actually good to go there. This was method 1 again, making sure that each number had the same exponent. Now, method 2. Remember, method 2 is converting it to standard notation. Now, these are both really small numbers. So 8.41, I would have to move my exponent 5 times, and I need to make it a small number that starts with 0 because it's a negative exponent. Where the other number, I have to move my decimal 6 times, make it a small number because it's a negative 6 exponent. All right, so if I move it a bunch of times, I get these 2 numbers. So if you notice, this would be a drawback because maybe some students don't move it enough by accident. Maybe they miscount it, or maybe on the calculator they mistype it. So when you do your subtraction like this on the calculator, are you actually typing the correct amount of zeros? I sure hope so. That's why I kind of prefer method 1. Some students might like method 2. Now that I've done my subtraction correctly, I need to make sure my answer is truly in scientific notation. Again, it's a 1 through 9 option. Move it a bunch of times. Let's see here. 1, 2, 3, 4, 5. And since it's a small number, it has a negative 5 for the exponent. Beautiful. All right, so with your assignment again, you're going to go ahead and practice your addition subtraction. Now, if it's a word problem, try and look for those key words that tell you if you are adding it, like the increase, or if you're subtracting it, like the decrease, something like that. All right, be awesome, students.